All right, section 9.1. This is coming out a little late. 9.1 is all about finding patterns in numbers. That's something that we inherently do a lot, is find patterns, maybe not in numbers, but we're going to take a look at some mathematical patterns and talk about a couple different ways to write an equation or a formula for the pattern that we see. So our EQ today is how can I write a formula to find the certain term of a sequence, and we'll talk about what those words mean in a minute. Here's determine the warm-up, just find the pattern. What are the next two numbers? So here I see from 8 to 15 is plus 7, 15 to 22, 22 to 29 is plus 7. So then if I kept that pattern going, my next two numbers would be 29 plus 7, which would give me 36. And then I'd go 36 plus 7 to get 43. So these would be my next two values in that sequence, or in that set of numbers that's called the sequence, and we'll get there in just a second. Here, I see that the pattern is not adding because it's flipping from positive to negative, but from 3 to negative 2 is multiplying by 2, negative 6 back to positive 12 times 2 times 2. So we see that the pattern is multiplying. Here then, if I multiply by, we're multiplying by negative 2. And that's why it's switching from negative to positive. So negative 2 times negative 2 times negative 2. So if I multiply by negative 2 again, I get positive 48. And then multiply one more time by negative 2, I will get negative 96. So there's no, this is just figure out what the pattern is and then keep that pattern going. Just to put some definitions to this, a sequence is a list of numbers, and it's in order. So the first number is just designated to go first, second number second, and so on. Each number in that list is what we call a term. So the first number in this list is 1, and we call that, so that's the first term in the sequence. And how we designate what term we're looking at is by the letter A with the subscript. And how you would say that out loud is A sub 1, sub meaning like subscript. So A sub 1 means what is the first term, and here that's equal to 1. If we jump to the end, the fifth number in the list is 9. So we say 9 is the fifth term. So A sub 5 equals 9. If you see this pattern is going by 2s, it's adding 2 every time, 1, 3, 5, 7, 9. So we could say the sixth term would be 11. The seventh number in the list, or the seventh term, would be 13, and so on. And we could keep going from there. Okay, so every number in the list is called a term, and to show what number term we're talking about, which number in the list, we use the letter A with the subscript. So sequences and terms. I'm going to use those words quite a bit. We're going to write two types of formulas. The first one is an explicit formula. Called an explicit formula is because it allows us to jump to any point in the sequence. It allows us to jump to let's say we want the 50th number, or we want the 305th number. We can jump right to that number in the list without having to build the list all the way up. By using the number n. So you can find the nth term, whatever term you want, pick a number, by actually using that number n. So this is how it'd be written, A sub n. So again, this is the term number. Not the actual value of, but just what do you want, the fifth term? Do you want the 10th term? What do you want? And you're going to use that n value. So we are going to plug in the term number. So for instance, if I wanted let's just figure out what's the first term in this sequence. How does this sequence start? I'm going to plug in 1. 2 times 1 minus, 2 times 1 minus 1. Well, that's 2 minus 1. So the first number in the sequence is 1. If I wanted to jump, okay, cool, give me the 10th number in the list. I want to know, it starts with 1, but where are we at after 10 numbers? To find the 10th number, you would just plug in 10, and then subtract 1. So 2 times 10 is 20, minus 1 is 19. So that means the 10th number in the list would be 19, or the 10th number in the sequence. And again, you can jump all over the place. If I want to know what's the 153rd term, I just plug in 2 times 153 and then take away 1. So this is really powerful because it allows us to jump to wherever in the sequence that we want without having to list 1, 3, 5, 7, 9, and so on and so forth. So that's an explicit formula. It gives you the nth term by actually plugging in the number that you're looking for. Okay, so go ahead and if you want to pause this real quick, just check, see if you can use this new explicit formula, a sub n equals 3n minus 2, to find the 10th, the 50th, and the 353rd, not thirth. We already talked about this, but it's 753rd term. Okay, so here, to find 10th term, again, I'm going to plug in 10. And I can see that this is an explicit formula because the subscript becomes like regular sized. So that's one way to know that you're dealing with an explicit formula. We'll talk about the other formula in just a minute, or the other type. 3 times 10 minus 2, that'd be 28. So my 10th number in the list would be 28. The 50th number, or the 50th term, 3 times 50, that's 150. Take away 2, that's 148. If I wanted the 753rd term, a sub 753, I would take 3 times 753 and then take away 2. And to figure that out, I can just go to the calculator, 3 times 753, and then take away 2. And that's 2257. So our 753rd term in that list would be 2257. So like that's really helpful because I don't have to list out. I don't need to know what the first 752 numbers are. I can just jump to whatever value I want. All right, so that's how we use an explicit formula. What's not so easy is to, here's a pattern, now write the explicit formula. So the sequence here goes 0, 3, 8, 15, 24, et cetera, et cetera. So the first thing we have to do is figure out what the pattern is. And I see here 0 to 3, that is adding 3. 3 to 8 is adding 5. 8 to 15 is adding 7. 15 to 24 is adding 9. So I see a pattern there, right? I see that it's adding 2 every year. Well, I'm adding 3, then adding 5, then adding 7. So the amount I'm adding is increasing by 2 every time. So the easiest way to do this is we want to just figure out like a relationship between the term number and the value. Okay, so we're going to make like a little table here. The first term was 0. The second term was 3. The third term in the list was 8. The fourth term is 15. The fifth term is 24. Okay. And this isn't an exact science. I mean, there are some tips and tricks that you can learn along the way to use here. But you got to kind of just play around and see how can I go from 1 to 0 and do the same thing to get from 2 to 3, 3 to 8, 4 to 5, and so on. And what I'm seeing here is that if I were to take 1 and square it, right? 1 squared would equal 1. 2 squared equals 4. 3 squared equals 9. And I'm seeing that the value, the number on the right-hand side of my table, is 1 less than the squared number on the left. So if I were to take 5, which is the term number, square it, and then minus 1, that would be the same for all of these. N squared minus 1, n squared minus 1, okay? And I probably should put that up here. Term number is n. So if you want, so it looks like I found a formula for this. And that is that to find any term, so to find the nth term, you're going to take the number n, square it, and then subtract 1. So just to check if this works again, let's just plug in. If I were to keep this pattern going, that's plus 11. So the next number is going to be 35. And that's the 6th number. So to check to see if my formula works, I'm going to take 6 squared minus 1, Well, sure enough, that's 36 minus 1, which is 35. So we know that our explicit formula right here is good. Okay. Again, not an exact science. You're going to kind of just have to poke around and mess with some stuff. We will learn about a couple of specific types of formulas. But sometimes if you're just given a sequence of numbers, you have to just play around and see what you can find. So go ahead and see if you can figure out a way to write a sequence for this, or sorry, to write an explicit formula for this sequence. I see that I'm subtracting 4 repeatedly, minus 4, minus 4, minus 4, minus 4. And so my first term is 28, my second term is 24, my third term is 20, fourth term is 16, and fifth term was 12. So I see that's going down 4 every time. And if you think about like when we learned y equals mx plus b, or like equations for linear functions, it had a slope and then a y-intercept. So the fact that we're subtracting 4 from each number is kind of like the slope of this sequence. It's going down 4 every time. So I know negative 4 is going to have to be part of it. And again, this is tough because if you've already seen the 9.2 video, we have an easier way to write this function or this formula. But one way to write this is to say, okay, I'm going to take the n value and I'm going to multiply it by negative 4 because I know that's my pattern. So if I take negative 4 times 1, that's going to give me negative 4. But the first term is 28, not negative 4. So in order to get 28, I would have to add 32 to this. Okay. If I take the number 2, so if I look at the second term, negative 4 times 2 is negative 8. Whoops. But I want 24 as my second term. So sure enough, if I take negative 8 and add 32, I get positive 24. And we can see that this pattern continues. Negative 4 times 3 is negative 12. Well, the third term is 20. And if I take negative 12 plus 32, that gives me 20. So one explicit formula for this could be to find any term, you would take negative 4 times the term number and then add 32 to that. Okay. There are other ways to write this explicit formula. And again, if you've already seen 9.2 and you're going back to 9.1, we have an easier way to write this. But that's one way to go about it. So this then would be our explicit formula. Again, sometimes there's an exact like science to writing these. Sometimes you just got to try some stuff. Okay, so let's say a restaurant has square tables that each seat 4 people. There are 34 of us going out to eat, but we all want to all sit together. How many square tables will we need to push together in order to seat us all? So if you think about, if you go to a restaurant, right, you got a square table, one person sits on each side, but you have more than 4 people. So sometimes you can pull up another chair to that table and make 5 fit. But let's say we have a big group, so we're going to push a second table there. Well, this person had to stand up, right? This person's got to stand up while they move the table. They're going to be here. So now they're sitting right there at the table. And now we have, we're able to introduce 2 new people, right? So we got new person number 1, new person number 2. So now we're fitting 6 around that table. Again, if our group is bigger, than 6, and you take this table, that person stands up, I add another table, and then 2 more people can sit down with our group. And this pattern can keep going. So every time I add a table on, I'm adding 2 more people. So we could say the A sub 1 or 1 table seats 4 people. With 2 tables, I can seat 6. With 3 tables, I can seat 8. And we could keep going and going from there. And the question is, how many tables does it take to get to 34? To figure out how many tables it's going to take to get to 34, I could say I'm starting with 4. right? 4 people sits around one table. I'm going to keep adding 2 until I get to 34. Okay. So this is another way to to figure this problem out. So if I add 2, that's 6, which is for 2 tables. And I keep adding 2 plus 2 plus 2. Okay. And I can just keep building this up. Now, if I do 2 times n, okay, n would tell me how many tables I have to add on, because these 4 people were already sitting at the first table. So n is going to tell me the number of new tables that I have to add. And I want to end up with 34 people sitting there. So we can just solve for n here. If I subtract 4 from both sides, I have 2n equals 30. Divide by 2 on both sides, n equals 15, which means I need 15 additional tables, 15 new tables to add on to the first one. So overall, I would need a total of 16 tables. 16 tables. Again, many ways to solve this problem, as is with math. Like there's multiple ways to attack it. This is just another way to think about it. Okay, so explicit formulas were you want to jump to the 10th term, take the number 10, and do something with it. Plug it into some sort of equation. A recursive formula tells you the next term based on the previous term. So it tells you what the next number is going to be based on what the previous number was. So here's how a recursive formula looks. It says a sub n, so whatever term number you want, we're going to take a sub n minus 1. Okay, so n minus 1 being the term right before it. Okay, and you're going to add 2. That's what this recursive formula is telling us to do. If you want the next number, take the number you're at and add 2 onto that. Okay, and because the recursive formula uses the previous term, it has 2 parts. There's like the recursive formula part, but then you also have to tell what is the first term. Okay, so it would look something like this. To get the second term, you need to take the first term and add 2. So to get the second term, I have to take the first term, which was 19, and I'm going to add 2 to that, and that gives me 21. Okay. Well, to get the third term, I'm not plugging in the number 3. Okay, I'm not plugging in 3. I need to take the second term and add 2. Well, the second term we just figured out is 21. So to find the next term, to find the third term, I'm going to take 21 and add 2, which is 23. And then this pattern keeps going. If you want to find the fourth term, take the previous term, 23, and add 2 to get 25. And this goes on and on and on, like so. So like I can see the pattern really easily. The downside of recursive formulas is you can't just jump to like the 100th term, because in order to know the 100th term, you need the 99th term, and then you need to add 2 to that. Well, I don't know the 99th term, so then I would have to take the 98th term and add 2 to that. And this would have to go all the way back. So in order to find the 100th term, you need to build the entire sequence. So recursive formulas do have their place, but they're not very useful for like finding information way down the road. But there are 2 parts to it. It's the formula part, what do I do with the previous term, and then you also need to include the first number. So we'll try one recursive formula quick, we'll wrap this up. What recursive formula could be used for the sequence 8, 24, 72, 216, so on. So this is not adding because the numbers get real big real quick. But here I see 8 times 24 is times 3. 24 to 72 is times 3. I can check in the calculator, but 72 times 3 is 216. So what that tells me is to get the second term, I'm going to take the first term and, nope, not add. I'm going to multiply it by 3. To get the third term, I'm going to take the second term and multiply by 3. To get the fourth term, I'm going to take the third term and multiply by 3. So my recursive formula is going to say, to get the nth term, whatever term you want, you need to take the term right before, oh boy, you need to take the term right before it, which is n minus 1, and you need to multiply it by 3. And I have to provide you the first term, and we see that the first term there is 8. So this is going to be the recursive formula for it. Again, a pretty easy formula to write, but doesn't help me figure out the 10th term because I would have to just manually times 3 times 3 times 3 until I get to where I want. Okay. So that's kind of just the gist of 9.1. We're going to focus on these recursive and explicit formulas quite a bit. But for now, we will wrap this up until next time.